Now, when it has this little symbol, that means of. That doesn't mean multiply or times or a 0. And what we do here is we take this 1 and we plug it in the h first. So I'm going to take that 1 and I'm going to plug that 1 into that h. So that's going to give me negative 1 minus 4. And that actually equals negative 5 for h. Now what I do is I take that negative 5 and I plug it in to the f of x. So that's going to be negative 2. And now I have the negative 5. Not the negative 1. Not the 1. Ooh, the negative 5 minus 1. So negative 2 times negative 5. Well, that's 10. And then 10 minus 1 is 9. So it's called a composite function is what it's called. A lot of people really like this problem, so they tell us to use elimination. But what we're going to do is just use our Casio and hit mode 5, 1. And when we do that, an array of zeros will appear. So let's see if we can't do it. Mode 5, 1. And I don't know if you can't see this. And that array of zeros appears. And then all we do is we type in the coefficients. And the calculator just generates the answer pretty quickly. And you get 3 and negative 4. But do recall, you have to put an ordered pair. So it has to be an x value and a y value in parentheses. The next one is a large one. It's a really large one. And that's an ordered triple. Let me move that over. And for this really large one, it would actually take us about 12 to 17 minutes to do by hand. But again, on the Casio, we can just use mode 5, 2. And we're just going to type in the coefficients. So the array of zeros would be filled with 1, 1, 1, negative 1, and then 2, 1, negative 1. See how there's a negative in front of that? And then negative 12, and then 1, negative 1, 1, 1, negative 1, 1, 9, into mode 5, 2. So I'm going to hit the mode 5, and see how 2 has the x, y, and z, 2. And I have that big array of zeros. And again, I wrote those numbers down, so I'm just going to call them out 1, and then you hit equals, it moves over 1, 1. And then the d value was negative 1. And then the next row was 2, 1, negative 1, 2, 1, negative 1, negative 12. And then my last row would be 1, negative 1, 1, and 9. And you hit equals to move it over. Now I'm going to get an ordered triple. So I have x equals negative 1, y equals negative 5, and z equals 5. So those answers were negative 1, negative 5, and 5. So negative 1, negative 5, and 5. Not bad. This one is really challenging. This one is really challenging. When you type it in, I believe you get infinite solutions. So we'll see if we get infinite solutions or no solutions. Again, I'm going to implement mode 5.1, mode 5.1 to see if I can get my answer. And recall, the array of zeros I'm going to fill in with a 30, negative 6, a 54, a negative 5, a 1, and a 9. So that was mode 5.1, mode 5.1, and my coefficients were 30, negative 6, 54, and then negative 5, 1, and 9. And oh, no solution, that's a fun one. So when my answer is no solution, I'm just going to click on the solution set as the empty set. Not that bad. This one is really difficult. We cannot use the calculator for this one. I'm actually getting okay with this problem. So what I'm going to do is I'm going to beat it up twice. So I have the set here, and then I'm going to have the set over here. And I'm going to do quasi the same thing to it 2 different times. And here's what I mean by that. It says type an expression using x as the variable. So my first answer is going to be x. So I need a y value, but I have to figure out what y equals in terms of x. So I'm going to come up here, and I'm going to get rid of the z's. And the way to get rid of the z's is by elimination. So I'm going to multiply this top number by negative 4, and this bottom number by 9. And if I go to this third number here, you'll see why. Negative 4 times 9 is negative 36. And then 9 times 4 is positive 36. So those numbers, when I get done with this whole process, are going to eliminate. So let me distribute the negative 4. That would give me negative 4x plus 8y minus 36z. And then be careful, have to distribute it, equals negative 32. These are problems to mess up on the arithmetic, really easy one. So that's going to be negative, again, positive 18x minus 9y plus 36z equals 63. Now I'm going to go ahead and do my systems of equations elimination process. 18 minus 4, that's going to give me 14x. 8 minus 9 gives me negative 1y, or just negative y. These two numbers eliminate. And then 63 minus 32, that's going to equal 31. And now I'm solving this for y, so I'm going to add y to both sides. So I'm going to add y. That's going to give me 14x equals y plus 31. So my y value up here will actually be, 14x, and I have to minus 31 from both sides. Minus 31. And that's just my y value. Now I hope if you take the test, it's multiple choice, and you're done. You're done. That's probably not the case. So now I'm going to come over here, and I'm going to solve this one for z. So that means I want to eliminate the y. I'm going to have a z left over and an x left over. So let's see what I need to do to eliminate the y. Oh, I don't even need to multiply the top one. I'll multiply the bottom one by negative 2. That's going to give me negative 4x plus 2y. And notice, my plus 2y and my negative 2y will eliminate. Minus 8z equals negative 14. X minus 4x. X minus 4x is negative 3x. 2y and negative 2y. 2y minus 2y, that eliminates. And now I have 9z minus 8z. That's going to equal plus 1z. And then 8 minus 14 will give me negative 6. And remember, I'm solving this one for z to get that value for z. And notice z is going to equal 3x minus 6. So that value there is going to be 3x minus 6. Graphing. A couple of ways to graph. Some people, they might just want to solve it for y, and that's entirely okay. If you want to just get it in y equals mx plus b format, that's fine. I'm actually going to do it that way because some people don't like my shortcut methods, so I'm going to subtract x from both sides. And when I do that, that's going to give me 2y is greater than or equal to negative 1x plus 10. Now I subtracted x, so I don't have to switch the sign. Now I'm going to divide every item by that 2, and that gives me a slope of negative 1/2 and a y-intercept of 5. So my new equation is going to be y is greater than or equal to negative 1 over 2x plus 5. So I'm going to begin, my b value is 5 on the y-axis, and then my slope is going to be down 1 over 2. So I'm going to implement my slope. I'm going to go down 1 over 2. I'm going to go down 1 over 2, down 1 over 2, down 1 over 2, and it's going to give me a nice line when I continue that process. This is a Vux problem from Vux Hoy. So notice it's an X, so I imagine that the word Vux is there. So Vux, that means it's a vertical line whose slope is undefined at x equals 9. So I go over to 9, I place a dot, and it's a vertical line. So I'm going to do my line tool, and I'm just going to go straight up and down. Now it asks me to shade, and the arrow is pointing to the left. So I'm going to shade everything to the left of that vertical line. This is a parabola in vertex form, and we're going to find the vertex by doing opposite same. So the opposite of negative 1 is positive 1. The same as positive 1 is positive 1. So that's my vertex. I go to 1, 1, and place my vertex there. Now I'm going to implement 1, 3, 5. So from that vertex, I'm going to go up 1 over 1, up 1, 2, 3 over 1, up 1 over 1, up 1, 2, 3 over 1. And I'm going to graph my parabola as best as I can. Well, it's a dashed line. I don't know if we noticed that, but it's a dashed line because there's no line under that inequality. And now it says greater than. If it says greater than, that means I go greater than the vertex. If it were less than, I would go below the vertex. But because it's greater than, I'm going to go above the vertex and shade that zone. Now I have to graph two equations. First things first, let's graph one equation. So I'm going to solve this equation for y. So in order to do that, I'm going to subtract x from both sides. That's going to give me y is greater than or equal to negative x. So I begin, that's my b of 0. I'm going to begin at y value 0, and my slope is negative 1. So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. Notice it's a closed line, so it's not going to be a dashed line. I am supposed to shade above that graph. So I'm going to lightly remember the shade above the graph. Now I'm going to graph the other equation. This one's a little bit more involved because there's a negative in the question. So let me bring that graph down here. Now I'm going to look at this graph, and I'm going to solve that graph for y. There are a couple of ways to do it. I'm going to add y to both sides. That's going to give me x is greater than or equal to 2 plus y. Then I'm going to subtract 2 from both sides. Now I can't subtract 2 from x very effectively, so what I'm going to do is just write x minus 2 is greater than or equal to y. Now I'm going to switch it around so that it's in y first. So I'm going to have y is less than or equal to x minus 2. So this begin at negative 2 on the y-axis, and my slope is positive 1 over 1. So I'm going to go up 1 over 1, 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 and that's going to be a solid line as well. And notice here, it said, please shade below that graph. So I'm going to shade below that graph. Now on the test, you don't have this option, but you'll notice I have this area of double overlap, and that's where I want to shade. Now what some people will do is they'll test the point. So notice I have 3, 0 there. That coordinate is x value 3, y value 0. You can see if you shade it correctly by throwing a 3 in for the x and a 0 in for the y. 3 plus 0 is 3. Ask yourself, is 3 bigger than 0? Yes. So that's correct for the first equation. Now I'm going to throw a 3 in for the x and a 0 in for the y. 3 minus 0 is 3. Is 3 greater than or equal? Yes, 3 is bigger than 2. So that's the correct area to have shaded. Now on the computer test, you're not allowed to have any shading in these other areas. You're only allowed to do the area of double shading. Now I have to graph a parabola and a line. So the parabola is fairly easy. There's no line under it, so it's going to be a dashed line. So I'm going to begin, my vertex for that is 0, 0, and I'm going to implement 1, 3, 5. So I put my dot, I go up 1 over 1, up 1, 2, 3 over 1, up 1, 2, 3, 4, 5 over 1, up 1 over 1, up 1, 2, 3 over 1, up 1, 2, 3, 4, 5 over 1. And it's a dashed line because there is no equal sign with it. It tells me to shade below it, but I'll wait. Now I'm going to solve this for y. So I'm going to I'm going to subtract 3x from both sides. That will give me negative 2y is less than, not less than or equal to. I'm going to bring that negative 3x up front, plus 6. Now, this is the tricky part. I divide everything by negative 2. And when you divide an inequality by a negative, that sign is going to have to go back the other way. Notice a negative divided by negative is a positive. So this is going to give me y is greater than 3 over 2x minus, because 6 divided by 2 is negative 3. I'm going to begin at negative 3 on the y-axis, and then I'm going to go up 3, right 2. Up 3, 1, 2, 3, right 2. Up 1, 2, 3, right 2. Up 1, 2, 3, right 2. Up 1, 2, 3, right 2. And this is a dashed line. And now it wants me to shade above that line, and below the vertex. So above that line and below the vertex is going to give me this huge zone out over here. So everything above the line and below the parabola. Two lines. This one's a quick move. So I'm going to subtract x from both sides, and that's going to give me y is less than or equal to negative x plus 2. So that's it. It's got a line under it, so it's going to be a solid line, negative slope, and I begin at y value 2. So I go to y value 2, and I go down 1 over 1, down 1 over 1, down 1 over 1, solid line when I finally draw my line, down 1 over 1, down 1 over 1. Let's draw that solid line. And now the other graph is going to be a parabola, and it's already solved for me. So my vertex for this, there's nothing grouped. So my vertex is going to be 0, because I can't take the opposite of anything, negative 3. So I'm going to begin my graph at 0, negative 3. I'm going to implement 1, 3, 5 when I have a parabola with no leading coefficient. I'm going to go up 1 over 1, up 1, 2, 3 over 1, up 1 over 1, up 1, 2, 3 over 1, up 1, 2, 3, 4, 5 over 1. And it's going to be a solid line. And this is quite a cute graph because they want me to shade below the line and above the vertex of the parabola. So when I do that, I'm going to be shading this little zone inside.